Today I am going to discuss about the electron volt, which is also represented by EV. But before this one, I would like to remind you once again what is the potential difference, which already I have discussed in the previous video. Suppose Q is any source charge and whole this white board is the electric field of this charge Q. And suppose I am taking 2 points in this electric field. One point is A and other point is B, where point A and B is lies in the field of this charge Q. And now our aim is to find the potential difference between these 2 points B and A. So for this purpose, we will take a test charge plus Q naught and we calculate the work done in taking the charge from B to A, and suppose the work done in taking the charge from B to A is W. Then potential difference, here I am taking the charge from B to A. B is initial point, A is final point. So potential difference is given by VA. VA means V in final state, means potential in final state, minus potential in initial state. This potential difference is equal to amount of work done W divided by magnitude of the test charge. In other words, also you can say, when a charge Q naught be taken from B to A, then what is the work done in this process? So you can say this work done in taking the charge Q naught from B to A is equal to Q naught into VA minus VB. It means if the potential difference between the 2 points is given, then you can calculate the work done in taking a charge Q naught or Q from one point to other point are under that potential difference by using this formula. Now, by using this one, also you can say here charge is a scalar quantity, and when you will calculate the work is also a scalar quantity. So here you will consider that sign of the charge. If that charge which you are taking, that one is a positive, then work done will be positive. And work done positive means, it means work is done by the external agent. And if Q naught is negative, then work done will be also negative. In this case, you can say work is done by the electric field itself. So please be careful about this one. When you will take the charge Q naught, then also you will mention a sign. Here if positive charge you are taking, plus sign. Negative charge, then minus sign. And in same way you will get the value of W either positive or negative. Now I am going to define what is the electron volt. So actually electron volt is a very small unit of work or energy, which is commonly used in the atomic physics. And how can we define the 1 electron volt? So 1 electron volt is the work done in taking 1 electron from one point to other point when the potential difference between these points is 1 volt. Or in other words, also you can say 1 electron volt is the kinetic energy which an electron acquires when accelerated through a potential difference of 1 volt. It means, suppose AB is 2 points and potential difference between A and B is 1 volt. So when an electron be taken from one point to other point, suppose potential at the point A is VA, potential at point B is VB, and potential difference between B to A means final VA minus VB is equal to 1 volt. Then how much work is done in taking an electron from position B to A? So by this formula, W is equal to Q into VA minus VB. And here VA potential in final state, VB potential in initial state. And here Q means you are taking one electron. So what is the charge on the electron? 1.6 into 10 to the power minus 19. And VA minus VB is how much here? 1 volt. And in this way you can say this is equal to 1.6 into 10 to the power minus 19. What here? Joule. It means 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. So simply you can say 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. It means when an electron be accelerated through a potential difference of 1 volt, then the kinetic energy acquired by that electron is how much here? 1.6 into 10 to the power minus 19 joule. Now, next topic is electric potential due to a point charge. Like electric field due to a point charge, here I am going to calculate electric potential due to a point charge. Let a point charge plus Q be situated at point O in air or vacuum. I am taking here air or vacuum, means here K is equal to 1. And suppose P is a point in the electric field of this charge Q at distance R from it, where electric potential is required or where we calculate the electric potential. So according to the definition, what we will do? First we will take a test charge plus Q naught suppose, and that test charge will carry from infinity to the point P, and suppose the work done is W, and when that work done is divided by the magnitude of that test charge Q naught, then we will get the electric potential at the point P. But for this purpose, how can we calculate? Let us consider from infinity to the point P, I am taking any 2 points between infinity to the point P, and suppose one point is A and other point is B. Suppose that charge plus Q naught, that test charge, is carrying from infinity to the point A, and when that charge Q naught was at the point A, its distance from charge plus Q is x. So when that test charge be placed at point A, then it experiences a Coulombian force. This one is plus Q, this one is plus Q naught. So this charge will apply a repulsive force on this charge Q naught, and that repulsive force F is equal to 1 upon 4 pi epsilon naught Q naught upon x square. Q naught upon x square. X square. This distance is x, and this force is repulsive. And now, when this test charge be displaced from A to B, means displacement is taking place along this. When this charge be displaced from A to B against this force, then we will do the work. And since this displacement is small, so work done will be also small. And all of you know work done is equal to, work is equal to F d cos theta. So here this displacement dx is small, so work done will be also small. And how can we calculate the work done? dw is equal to F dx and cos theta. Theta is 180 degree. Why? Because force is towards right and displacement is towards left. So angle between them is 180 degree, and this will comes minus F dx. And F is how much? 1 upon 4 pi epsilon naught. So you can write minus 1 upon 4 pi epsilon naught Q naught upon x square into dx. This is the work done in taking this test charge plus Q naught from A to B through a small distance dx. But our aim is to calculate the work done in taking the test charge from infinity to the point P. So for this purpose, we will integrate this term. So now you integrate this term dW. Hence, the work done in bringing the test charge plus Q naught from infinity to the point P. When the test charge was at infinity, then its position x was infinity. And when the test charge be placed at the point P, then this x becomes how much here? R. It means we will integrate this term dW within limit infinity to R minus 1 upon 4 pi epsilon naught Q naught upon x square dx. Here infinity initial position of the test charge and R final position of the test charge, and the test charge is taking from infinity to the point P, means earlier distance infinity and final distance is from point O is how much here? R. So integration of dW, W, and here minus 1 upon 4 pi epsilon naught Q naught you take outside, this one is a constant term, and here infinity to R 1 upon x square dx. And I hope maybe all of you know integration of 1 upon x square dx is equal to minus 1 upon x, which already I had given in the class 11th. How can we find the integration of 1 upon x square dx, which is equal to minus 1 upon x. So here you can say W is equal to minus 1 upon 4 pi epsilon naught Q naught, and at place of 1 upon x square, integration of 1 upon x square dx, you write down minus 1 upon x, and its limit is infinity to R. And now you take minus outside here, so this minus becomes plus, so this becomes Q naught upon 4 pi epsilon naught, and here 1 upon x, and this one is infinity to R. Here R upper limit, infinity lower limit, and now you can say W is equal to Q naught upon 4 pi epsilon naught, and first at place of x you will write the upper limit, which is 1 upon R, minus again at place of x you will write the lower limit, 1 upon infinite, and 1 upon infinite is 0, so you can write this is equal to 1 upon 4 pi epsilon naught Q naught upon R. And remember this here, 1 upon infinite you are considering 0. So you can say the work done in taking a test charge plus Q naught from infinity to the point P is given by 1 upon 4 pi epsilon naught Q naught upon R. W is equal to 1 upon 4 pi epsilon naught Q naught upon R. But by definition, electric potential at the point P is the ratio of work done in taking the test charge from infinity to the point P, which is W, and to the magnitude of the test charge Q naught. So you can say this is equal to 1 upon 4 pi epsilon naught Q naught upon R, and this one is already here Q naught. Now this Q naught is cancelled by Q naught, and you can say electric potential V is equal to 1 upon 4 pi epsilon naught Q by R. Dear student, always remember this, electric potential V due to a point charge plus Q at distance R from it is given by 1 upon 4 pi epsilon naught Q by R. And since electric potential is a scalar quantity, so when you will calculate the scalar quantity in electrostatics, then always you consider the sign of charge. If that charge is positive, source charge is positive, then here plus Q by R. And if the source charge is negative, then here you will take minus q by r. Be careful about this one. Even you are not taking the sign of the charge in electric field or Coulombian force or in electric dipole moment. Why? Because all these are the vector quantity. But when you will calculate the scalar quantity in electrostatics, then always you consider the sign of the charge here. And V is equal to 1 upon 4 pi epsilon naught q by r. This volt. Even electric field due to this charge plus q at distance r is how much here? 1 upon, when you will take electric field due to this point charge at distance r, is equal to 1 upon 4 pi epsilon naught q by r square. Here electric field is inversely proportional to the square of the distance, while the electric potential is inversely proportional to only the distance, not square. So here r square and this one is a r. And when you will draw the graph between electric field and potential with respect to distance r due to a point charge, then electric field is inversely proportional to r square. So that graph is more steeper given by this one here. And electric potential V is equal to 1 upon 4 pi epsilon naught q by r. So that one is given by this one here. And once again I want to tell you, if the source charge is negative, suppose this charge is negative minus q, so due to this charge at distance r, the electric potential V is equal to, at point P, electric potential V is equal to 1 upon 4 pi epsilon naught minus q by r. Here we consider the sign of charge, or simply you can write here minus 1 upon 4 pi epsilon naught q by r. So dear student, once you will go through this derivation, and in the next video I will discuss the next topic. Thank you.